right, let's come to the term automatic repeat request. Okay, you don't need to remember those concepts by heart. Just remember here we have the term automatic, and then it's repeating, and it's being automatically repeated based on a request. Okay, now ARQ is another method used to check whether data has been correctly transmitted. It uses an acknowledgement, a message sent by the receiver, indicating that data has been received correctly. And timeout, this is a time allowed to elapse before an acknowledgement is received. If an acknowledgement isn't sent back to the sender before timeout occurs, then the message is automatically transmitted. Let me just explain to you how does ARQ system function. Okay, we have what is known as the sender here. Let's say it's your friend, okay, and this is your receiver here. We have the sender and the receiver. Okay, your sender is your friend who's going to send you beautiful gifts, okay, and this is normally you as a receiver. Now, when a friend sends you a gift, okay, let's assume we are in confinement and your friend sends you a gift. Now, you know you're expecting a gift from your friend, so you just wait for the gift to come at your place. Maybe police, the postman is going to drop that packet at your place, so you'll be waiting for that gift. Let's assume you have received that gift. Now, your friend doesn't know that you have received the gift. What you're supposed to do is you're supposed to tell your friend, okay, I have received your gift. Okay, you have to acknowledge that you have received your gift. Okay, and this is how normally ARQ function. If you have not received the gift, means that the postman has not delivered it, and the sender has to, your friend has to go ahead and research for that gift. Maybe it's stuck somewhere, and so on, right? So let me show you in between sender and receiver. Data on the internet are normally sent in the form of packets. So this is sender. Sender is going to send you the packet, right? Let me draw a line. Okay, sender is going to send you send the receiver a packet. Now, receiver at its end, when he receives the packet, he'll have to send an acknowledgement back. Okay, he has to send an acknowledgement back. Now, there's a few important things. You can keep waiting for your friend's answer all day, just to know whether he has sent the gift and the year is already over. Yes or no? Okay. I mean, you send your friend a gift and then you keep waiting for his answer 1 day, 2 days, 3 days, 4 days, 5 days, no answer from him. It won't be okay. There must be a time limit. Okay. After that, you held to it if you have not received the gift. But here, if I receive an acknowledgement, I know, yes, the packet or the gift has been delivered. If not, I'm going to resend that back to him. Okay, so how does ARQ function? First, sender is going to send receiver a packet, which is here. Now, upon receiving the packet, the receiver sends an acknowledgement. Yes, I have received your packet. But in case the receiver has not received a packet, he's not going to send an acknowledgement. Okay, but there will be a timeout. Okay, sender is going to wait for 5 minutes. If I receive an acknowledgement, it's okay, the packet has been delivered correctly. If not, I have to resend it back automatically. Okay, so just to do a recap, sender and receiver, they are sharing a packet. So I send the packet to the receiver. Now, sender has a time limit. Within that time limit, he's going to wait for an acknowledgement. If the packet has been received correctly, this is known as acknowledgement. If no packet has been received, the packet will be sent automatically again to the receiver. This is why we call it automatic repeat request. How does that repeat request get executed is based on the timeout, the time allowed to elapse before an acknowledgement is received. This is ARQ. If you just understand in the basic of what I've told you in terms of one friend sending a gift, you will be able to explain ARQ properly. Okay? Whenever we give a descriptive question on ARQ, we expect you to give us terms like acknowledgement. What is acknowledgement? A message sent by the receiver indicating data has been received correctly. Timeout is a time elapse before an acknowledgement is received. If not, the packet is resent automatically. Okay, to make you understand Echo Check, maybe you have been up a mountain hill and you start shouting just to hear your voice back, which is known as an echo. Okay? You keep on shouting and then you tell your friend, okay, listen, you're going to hear my voice back. This is an echo, right? Similarly, maybe if a classroom is completely empty with no chairs and tables, okay, if you try to make noise there, it's going to be echo. Okay, means it's creating a copy of your voice. Now, how does Echo Check function? Let me just show you in terms of diagram, and then we'll look at the theory. Right. Again, we have the sender here, and then the receiver. Right? Sender send receiver a packet. Right? Receiver get the packet. Right? Receiver get the packet, as you can see here. Now, receiver doesn't know if the packet is correct. The only way that we can ensure that is when this packet is going, sender echoes same packet. That is, he send another same packet like this one. Okay, these are same. This is the original one, and this is a copy one. So on receiving end, the receiver get the original one, and he get the copy one. Now, to know if there is if there are any errors, we're going to compare the original one with the copy one. This is why we call it echo. Whatever you're going to send a copy of that. With Echo Check, when data is sent to another device, the data is sent back again to the sender, a similar copy. The sender compares the two sets of data to check if any errors occur during the transmission process. Okay, so you can get these types of questions, explain what is Echo Check. So you can write it in your own words. It's sending the same copy of data so that the original one can be compared with a copy one. If they're not same, they are obviously errors. Okay? Before we leave on this session, let me explain you what is ARQ again. We have a sender. Okay? And then we have a receiver. What's important here is time. Okay? What's important here is time. When I'm sending a packet, I'm supposed to wait for an acknowledgement within a time limit. So here, I send the packet to the receiver, and this is a receiver, sorry. The receiver receives the packet at its side. Now, sender needs to wait for what is known as an acknowledgement, but this is done within the time limit. If an acknowledgement, what is an acknowledgement? It's just a small message that I received the data correctly. If no acknowledgement is received within the time limit, sender is going to send this back automatically. This is why we call it automatic repeat request. Coming to Echo Check, always remember echo is just like a voice echoing. Okay, I've taken an example of it on a mountain. Okay, you have again the sender, you have the receiver. Receiver is going to send a certain amount of information. Sender is going to send a certain amount of information to the receiver. This is my original packet, which I got here. Right? But at the same time, when this original packet is going, I'm going to send also a copy of that packet similarly. Now, the original packet will be compared to the exact copy of the packet. If they are same, no errors. If they're not same, there have been errors. So what may happen if I'm sending a packet to a given receiver or device, that original packet may be intercepted with an hacker, or error transmission may occur. But by sending a copy of that packet, I can easily compare whether errors can occur. Now, using error detection methods on computer system, obviously, one method is not enough. We always use a combination of all. Maybe your internet connection, it uses a certain amount of echo check, a certain amount of checksum, a certain amount of parity checking that goes on behind. There is one error detection method that has not been covered in this lesson, is check digit. It will be covered when we do revision on input and output devices.